Hi there, in this video clip today I want to talk about electrolysis. And why am I smiling? It's because this is about the 5th or 6th take I've done on this video clip today, because I keep on starting it and making mistakes. Anyway, let's get on today's video clip on electrolysis. Electrolysis is a chemical reaction that occurs when current is passed through an ionic material, and the ionic material can either be a molten compound or a compound in water that contains ions. Let's go straight and look at an electrolytic cell. Here is a vessel, and it contains an electrolyte. I'll talk more about that in a minute. And I've got 2 electrodes, and let's say they're made out of graphite, and I'm going to connect them to a battery. This is the positive side of the battery, this is the negative side of the battery. This positive electrode is called the anode, and the negative electrode is called the cathode. So what I've got is the electrolyte, positive electrode, and the negative electrode. Let's look at some molten electrolytes, such as, let's take lead bromide, PbBr2. Let's take common salt, NaCl, sodium chloride, and let's take one more, aluminium oxide, and they are ionized, i.e. in a molten state. What they produce is lead produces lead ions in a molten state, and bromide negative ions. I'm going to look at them again. Let's look at lead bromide in a molten state. It has Pb2 plus ions and bromide minus ions. Sodium has sodium ions and chloride ions. And calcium chloride has calcium 2 plus ions and chloride ions, and aluminium has Al3 plus ions and oxide ions. What happens is I turn on the juice. Would you believe this? The positive ions, there they are, the positive ions go to the negative electrode, and the negative ions go to the positive anode. So if we electrolyze something like lead bromide, lead goes to the cathode, it's the positive there, and let's take sodium chloride, the chloride goes to the negative electrode. But obviously this is the key point. If I've just said this, lead ions go to the cathode, therefore they must, if it's going to form lead, gain electrons, because the lead Pb here is neutral. the metal is neutral. And I just said this, that the anions go to the anode and they must lose electrons to become neutral again. Okay. So, to summarize, what I've said is, if I took the example lead bromide, here is the cathode, and here is the anode. I electrolyze lead bromide. What do I get? I get lead deposited at the cathode and bromine, a vapor, comes off at the anode. Let's take sodium chloride next. Sodium at the cathode, chlorine at the anode. Calcium chloride, calcium deposited at the anode, and chlorine gas comes off at the anode. And the final one, I said aluminium, Al2O3. By the way, that's the naturally occurring ore of aluminium, bauxite. And how do they get it out of the ground? They take it out of the ground and it's electrolyzed to give me aluminium and oxygen gas. So that's electrolyzing compounds in a molten or fused state. Let's now focus our attention on liquids, aqueous solutions. Let's take water itself, H2O. I add a drop of acid to that to make sure it's completely ionized, and when I electrolyze water I get hydrogen and oxygen gas coming off at the cathode and oxygen at the anode, because what's happened is the hydrogen ions have migrated to the cathode and the oxygen, the hydroxyl group has migrated to the anode to give me oxygen. Now, let's look at solutions next. Suppose I've got something like this sodium chloride solution. So when it's in water, it contains sodium ions and chloride ions. And don't forget, if it's in water, it also contains hydrogen ions and hydroxide ions. So here's my two electrodes. Here's the cathode, and here's the anode. This is what happens when I electrolyze salt water solution, sodium chloride solution. I get hydrogen gas and chlorine gas. I don't get sodium and the oxygen, and this is why. Sodium is found above hydrogen in the electrochemical series, and therefore hydrogen is preferentially liberated. And in this case, chlorine is preferentially liberated instead of oxygen. Let's change the position now of something in the electrochemical series, copper is found below hydrogen in the electrochemical series. So let's look at the electrolysis of copper sulfate. It contains copper ions and sulfate anions, and it also contains hydrogen ions and hydroxide ions. Now, copper is found below hydrogen in the reactivity electrochemical series, and therefore when I electrolyse copper sulfate solution, I get copper deposited at the cathode, and this time I get oxygen liberated at the anode. In general, if I've got sulfate ions, SO4 2 minus, and if I had nitrate ions, and if I had carbonate ions, generally, notice that word, I've said it a couple of times, generally I get oxygen gas liberated. However, life's not straightforward. If I've got a chloride, a bromide, an iodide, halide ions, I get them preferentially liberated compared to oxygen. So if I've got sodium chloride, I'm going to get chlorine gas. If I had potassium bromide, for example, I'd get bromine vapor. And if I had something like lithium iodide, I'd get iodine liberated. Well, that's all there is to electrolysis. I've mentioned anions, cations, cathode, cations, and the position of the elements in the electrochemical series. And that's it, folks.